So for our first reaction, we're going to do an oxidative cleavage of an alkene. So a reactant is a methyl cyclohexene. Our first reagent is going to be ozone. They interact in this way. So there's the methyl cyclohexene, and here's ozone. These are going to be electrons, and one of these electrons is going to form a bond with this carbon, and this double bond is going to form a bond with this oxygen. Then this double bond is going to be turned into electrons and move into that middle oxygen. This gives us a product known as ozonide. This is what ozonide looks like. Not enough room, so I'm going to redraw this. And then our second reagent is going to be dimethyl sulfide, or DMS for short. This reagent is going to dissociate the ozonide right here, and we are going to get this product. So our second reaction is going to be a thin hydroxylation reaction. Our reactant is also going to be a methyl cyclohexene in this problem as well. And our first reagent is going to be osmium tetroxide. And so it reacts in this way with the methyl cyclohexene. So here's osmium tetroxide. Alright, so this double bond is going to interact with oxygen to form a bond. Then this double bond is going to turn into electrons onto the osmium. And finally, this double bond is going to form a bond with this carbon right here. So we get an osmate ester, which looks like this. Here's the methyl group. Alright, and now water comes into play with our second reagent, which is, I'm going to write down here, NaH2SO3 and water. So the water molecule, the oxygen on it is going to attack the osmium, and then the oxygen that's bonded with the cyclohexane is going to attack the hydrogen. And then this is going to happen on both sides, so the other oxygen will also interact with a water molecule. And then as a result, our product is a diol, which looks like this. So for our third reaction, we're going to do a hydroboration oxidation of an alkyne. So here's our alkyne group, we're going to add in R2BH, a peroxide, in this case we're using H2O2, and an AOH. So this alkyne is going to react with the reagents to form an enol, which looks like this. And this enol, which is never isolated, is going to react with the hydroxide group. So this hydrogen is going to bond with this oxygen to form a water molecule, and then this bond will react with will go back to the oxygen as electrons. So we get this product as a result, and then this product is going to resonance stabilize into an alkylate ion, and thus by using these electrons, this pair of electrons on the oxygen to form a double bond, and this double bond is going to be turned into electrons on this carbon group. So here is our alkylate ion group. Then this alkylate ion is going to react with water. This hydrogen on the water molecule will form a bond with the carbon group through the electrons, and then as our end result we get a aldehyde. For our last reaction, we're going to do an alkylation reaction of an alkyne, obviously. Here's our alkyne. It is going to react with NH2. So this alkyne is going to react with an NH2 essentially, because when the NaNH2 is added, it dissociates. So we have an NH2 group, and the nitrogen will have electrons. So it's going to pull the hydrogen on this carbon to this nitrogen, so that our alkyne will have an electron on the carbon group, which is known as an alkylate ion. And then we add our second reagent, which is Rx, and it will add bond on to this carbon through the electrons, and then this halogen group is going to be kicked off. So in the end we get this alkyne.